So guys, demand forecasting is one of those problems that look fairly easy and solved, right? That's not so much the case. But as we'll see through this exercise, that these problems typically, while there are a lot of tools and stuff already built out, uh, in terms of driving outcomes, it's still fairly tricky, and largely so because there are a lot of other variables besides what we see in the time series data, which affects demand, right? And capturing that nuance, capturing those variables is key to getting these forecasts accurate, right? And despite your best of attempts, we will not get to the most, you know, 100, like not 100% accuracy, right? Given that the subsequent design of inventory or how many products to order and all, right, needs to be thought through, planned for the variance. Here in this exercise, I'm going through a sample data set from Walmart, which is a contest on Kaggle. We're not dealing with daily sales prediction stuff. We primarily have a prediction for different categories of clothing, and we are supposed to predict the sales for the entire month for the specific year, right? And there are broadly three categories of products, which makes it slightly easier, right? Uh, so we have training set going from 2009 to 2013, and the the submission is supposed to be on 2014. But yeah, for in the context of this video, primarily interested in how do I approach a problem like this, right? So besides the time series of sales or period of time, we also have exogenous or variables other than a time series, like the holidays data, right? So holidays primarily are key days or events where the pattern of behavior for these sales typically changes, right? So there are either a spike or a drop in certain categories of products. So holidays definitely key exogenous variables to be added. Uh, the other ones are macroeconomic data, right? This broadly covers things like CPI, CPI, what is the employment rate, and so on and so forth. This is important because this gives you a sense of how the economy is doing, how inflation is looking like, which at some macro level would have an impact on people's buying, right? And then finally, we have the weather data, right? Since we're dealing with categories of clothing, so weather data is also key because temperature, humidity would change, dramatically changing or being different from typical seasonality might provoke people to probably purchase more than they used to and stuff like that, right? So temperature, humidity and stuff and other variables like that are key to understand the seasonal patterns beyond the obvious, like the start of winter, summers, and like that, right? Uh, so in this exercise, I broadly have four sets of hypotheses, right? One is obviously we're predicting, sales basis this time series data set, right? But besides that, we have these three external variables, and which is what we want to account for, like whether as will affect or give us a sense of start of the season, end of the season, and how intense the seasons are. And macroeconomics data will give us a sense of how, just to recap, right, how the economy does. And holidays are primarily give us those. Not all holidays are the same, but some of these holidays might give us a sense of days or specific events where you might see a spike in sales in general across the board, right? And for this specific exercise, I'm using Nixla, which is a pre-trained transformer-based time series forecasting model. This allows us to inference or make predictions right off the bat without having to train it. You can fine-tune it if needed, but it also allows us to use it off the bat straight away. So we'll also be exploring and understanding how it works out for this specific case, right? Yeah, the details will be in the next video.